We start.
Yes, sir.
Visible to everyone?
Yes, sir.
Okay. Now the next one, that is a piston wall. Piston walls visible in construction move toward a globe wall and are used shut off and regulation operations. These walls provide positive shut off in process industry. The shut off assembly consists of a metal pistons. See here you can see the different parts of this piston wall. So here the consist of metal pistons, two resilient wall rings, lantern push, ceiling surface, consist of vertical face, piston, and then in ceiling rings. This provide a face to wall of conventional pistons. Basically, piston walls are of two types. First one is balanced, another is unbalanced. See, in balanced walls are used in high services. When we use the balanced walls, it is used in high pressure services and unbalanced one for low pressure services. Here two types of piston walls. First one is a balanced, another is unbalanced. And balanced walls are used in high pressure services and unbalanced one for low pressure services. And the main parts of the wall are body, upper, lower wall rings, London bush, piston, spindle, bonnet, stud, nut, washer for bonnet fittings, hand wheels, and nut plus washer for hand wheel fittings. So this is the assembly of piston rings. And you see the another assembly or detail of piston diagram walls. So here you can see all components. So in assignment or exam, you have to draw this line diagram only. And here all parts are mentioned like we are studied in bill of material. So in bill of material, we have to return the name of the parts and material code. This is a new one material code as per the piping engineering. So we have to write down the material code and part names and materials, what kind of materials are used for particular parts like body. Here we use the cast steels and as per the ASTM A216 grade WCB. So that kind of codes we have to use for the material cast steels and we are used for the body parts. Now next is a bonnet. That kind of parts are there in piston rings. So these are the main parts, the piston walls. Here we can use the different parts. Based on that, we can identify it. So basically, body is normally of cast construction. It can have screw ends. What we have studied the different kinds of ends. So here it can have screw ends, flange ends, or butt welding ends. So these walls follow the regulatory codes to DIN, DIN. That is a Dutch standards. We call the DIN, DIN. There are no API or ANSI standards. So petroleum institutes covering the piston walls. Therefore, there are no API or ANSI standards in the piston walls. The end-to-end dimensions are to DIN 3202, which is more than a gate or globe wall, same size for API, NSI. Another standard is a BS, that is a British flat. The British, as per the API, NSI, and BS standards. The piston walls are all made to ANSI B16.10 dimensions, and the end connections are available to ANSI and BS standards. So, above the standards, these end connections are available in piston walls. Now, the bonnet. Next part is bonnet. Bonnet is of the same material as that of the body. So here we can use again the CS body as well as bonnet. So bonnet is also of the same material as that of the body, and it is of bolted construction. The piston along with two resilient seats provide proper sealing. The upper wall ring seal to atmosphere and the lower wall ring provides seal across the pores. The lantern rings serve as the distance piece between the two rings. Now, there are two types of piston design available in markets for processing industries, chemical industries or petrochemical industries or pharmaceutical industries. First one is a regulating type and another is normal. So in regulating type, the bottom part of the pistons is tapered have throttling effect. Maybe you have studied the throttling effect in fluid mechanics. So no need to explain again what is the throttling effect. Here regulating type and normal walls. So in regulating, the bottom part of the piston is a tapered to have throat effect. The sealing rings are of the piston walls. The sealing rings are made from specially highly elastic material or graphs. The materials are selected depending upon the service conditions for which the wall is used in this pressure temperature condition. So based on that we can take the material for the services. Spring washers are fitted under the bonnet nuts to ensure that the pressure of the bonnet on the wall ring is kept constant. This, along with the resilient sealing rings, produce a spring action, which compensate for many or a differential expansion that can occur the piston wall rings. So we call the differential expansion that occurs. Therefore, can consider different types of stems designs available in piston wall rings. First one is inside screw rising stem, and another is open, short, and wide type with rising steps. That kind of steps are available in piston walls. The hand wheel is of the rising design and OS and Y type. A stepping box with bolted gland is provided. This design is mainly used for thermic fluid or high temperature services. Piston walls are prepared by maintenance people and they need lesser attention. Therefore, they call it as fit and forget type of wall. They call it is a fit and forget type of wall. So this is all about the piston wall. Now next wall is diaphragm wall. So this type of walls are mainly used for low pressure corrosive services. Set of walls. These are also used for the moves up and to operate the walls. So wall with plastic body also manufactured in Italy. And there are two types of walls uh, for this sketch and this of the staff of you can visualize all different components of diagram walls, and another one is line diagram. This diagram is required in assignment as well as near MST or ES exams. So kind of essential to draw. There is no need to draw the 3D sketches of walls. We focus only on line diagrams. So here different components shown in this line diagrams. Before that, I will see there are different types of diagram walls. Basically, two types of diagram walls are available in the industry. They are the wear type and straight fit. They are like of walls where type is straight walls. Most common use one is type, and opposite it is popular the sound resistance type. Body configuration is such that rotation as well as control is possible in this uh, type of watch. Now, so the typical diaphragm walls having different ports. Beyond that, we can identify the diaphragm walls. So basically, we call the O-rings, diaphragm plate, gaskets, series, and intermediate plates, and dual pins, bonnets, body, stems, and seat retainers, and seat plates, and guide bushing. So we'll see some parts. Uh, brief discussion about the body and bonnets are made up of CS material, that is casting materials. The material of construction, the body depends upon the service for which it is used. The body can also be lined with corrosion resistant material like PTFE, means polytetrafluoroethylene, glass, rubber, etc. That kind of materials used, and depending upon the corrosive nature of the fluid or could be entirely made out of plastic materials. The diaphragm is normally made from an elastic material like PTFE fibers. The diaphragm press against the body to give positive shut. The port can also be adjusted by controlling the position of diaphragms, which is being done for control applications. The diaphragm is secured between the bonnet and body. Here you can see the diaphragm it is between the bonnet and the body. And compressor to the diaphragm relates up movements. So there are two types of designs possible. They indicate meetings will walls are not static. The position of the spindle indicates opening of the wall effect hand wheel in a manually operated walls. The material of construction of the hand wheel could be ductile or malleable iron or even plastics. The body ends could be flange, screw, or butt welded, as required in processing industries. In case of diaphragm wall with line body, the ends are always a flange and lining extends to the flange surface. Can use kind of flange surfaces. The use this wall is the they can withstand a maximum operating pressure of 7 to 10 kPa. The damage to the diaphragm occurs, and hence the maintenance is more frequent. On line walls, spark test is also conducted in addition to the test. This to ensure that the line is continuous and no occurs. There are no API or ANSI standards for this type of walls. These are covered by British standard and MSSP standards. So this is all about the diaphragm walls. They are covered by British standards and uh, MSSP standards. So it's about the diaphragm walls. Next wall is butterfly walls. So butterfly walls are positive set of quarter wall, and there are major parts. These butterfly walls. You visualize the three butterfly the different parts. Stems, body, residency is different parts will see in diagram different shape. So here we can visualize the flag. When you open the entire wall, then we can mark all the beads, needs, see or see breathing that kind of the major parts in butterflies and it's very impossible in butterfly parts. So this butterflies different body design is possible. It's like get all parts. That is 24 parts in butterfly balls. So there are three types of body design possible in butterfly balls. They are the double flange types. First one is double flange type. Now next is wafer lug types, and third one is wafer types. So in the double flange body design, the disc is contained within the body and is fitted to the pipeline like any other conventional walls. These type of walls are used rarely, as the advantage of sandwich design is not available with the same. Next, the wall is available type and wavelengths. The was designed to meet isolation between ANSI or DS or DR flanges. There are different designs available in types. In certain designs, the body aligns the resilient material like nitrile rubbers, ethylene propellants, diamine monomers, while the EPDMs. And another material is PTAP, that is polytetrafluoroethylene, EPDM, and PDFs. So that kind of resilient materials are used to design the body. The metallic disc with or without coating ensures proper sealing against the by selecting proper disc material. This type of wool can be used for cooling services. Could be any of materials. No near the installation of this wall. Certain other designs provided soft manner. The fluxes against the seam edge tenderly rolled. The this is a block PTFE material with certain reinforcements. The extra support required when design the with the P material. Is designed to replace with PTFE seams when worn out. Another design, the offset shaft and eccentric designs, which imparts the disc. It is the same center line. See, here you can see the same center line. Same center line. The center line. The out on point. I what moves tightly in for reliable sitting around the entire seats. The difference between the wafer lug and wafer body design is that the former has provision for all the stud to pass through the body, whereas the latter has provision for only locating bolts. See, this is the difference between the wafer lug and wafer type body designs. The wafer design is also called single flange design. What is called single flange design? As regards the shaft is concerned, there can be single shaft or a main shaft and a stub at the bottom of the disc. In shaft, as this the shaft seal can be with and wall design prevent emission or rising same walls. 12-inch nominal bore size are operated lever. This lever can have vision to control the flow. Higher diameter walls are provided with gear units and use the control wall. It can be provided with the actuator. The use of the above wall for high temperature is by the materials. Resiliency of metallic orbit for user pressure, but will not just walls for vacuum pieces. Pieces shall be provided with extra to patient when used with operations. Tight set of is troublesome since particles jams between the closer surface. Further, the wall must be strong to lift up the disc against the weight of the solids in the hopper. The advantage of these walls are that the wear resistance elastomer has a longer life expectancy than the conventional metallic seated. Even these walls use in high density mineral slurries. Other type of wall does not affect is as the encrusted scale will be weak when the wall operates and what flush away. The sleeve is the only melted part, and by selecting the right sleeve material, the wall body can be made out of low-cost material. As the design calls for no gland, there is no fixation and meets the API requirements. So, about the blast. Next is pinch wall. Pinch walls are also similar to diaphragm walls. In pinch walls, the body provided with sleeves, which get twitched to control or stop the flow. Here you can see the squeeze to control or stop the flow. The sleeve could be unresisted area like rubber TFE. Body made from cast iron is used for services. Service pressure are isolation of the whole section chemical industry. The body is and have finished or screw ends. Like Kepler developed this work to high pressure temperature. Here 0 to 100 bar 120 for in mining and mineral industries. These walls are so not covered under API or ANSI standards and are manufactured as per manufacturer standards. Now there are two types of pinch wall. So this pinch wall depends upon the body construction. So pinch walls are two types. One open pinch wall and second one is a closed pinch wall position. In open pinch walls, usually mechanically pinch walls are of open type without metal body casings. For inspecting the wall body visually and physically during the operations, the open construction of pinch wall is used. This is the most simple design, but the liner is exposed to the environment. Now, next is closed position, or we call the enclosed pinch wall. Enclosed pinch walls look similar to the globe walls from the outside. The housing is actually a protective casing for the liners. The pitching mechanism is housed inside the metallic casings. So it's the types of pinch walls and the wall is body lower pinch, upper pinch, spindle, hands. So these are the main parts. Based on that, we can easily identify the pinch walls. Now, what are the applications of the pinch walls where we can use pinch walls? Cement industries, plastic industries, pneumatic industries, waste or sewage treatment plants, ceramic industries, environmental industries, and vehicle work and solid use the walls front applications. Now next wall after application type of now regulating walls. In regulating walls, see the globe walls, pinch walls, diaphragm walls, needle walls, walls, and piston walls. These walls normally used in the plant to regulate or control the flow with the help of globe walls, needle walls, butterfly walls, diaphragm walls, and piston walls. That kind of walls used as a control flow walls or regulating walls. The feature of the butterfly walls, diaphragm walls, piston, and pinch walls were already explained under the isolating walls. There are many identical features in the construction of gate and globe walls. The gate first one is the of globe wall, the parts. There is the yolk component, what is seed, stem, bone, gland, and flange. So, this 3D sketch for globe walls. Now see the line diagrams and different parts here is line diagrams for the walls different parts. Here we can see the parts, points, body, disc, body, seats, stem, back seat, follower, yoke nut, hand wheel nut, stud bolts, nuts, stud bolts, and nuts, scales, and the body, the construction of the body differs from that of gate walls. The body parts are arranged such that the flow is from the undesirable of the disc. Through the code specifies that the globe wall shall be designed suitable for installation in either direction of flow. Prepare the direction of flow for the globe wall shall be from under the disc. Normally, the direction of flow is cast or embossed on the wall bodies. There are two types of ports design possible in globe walls. First one is a full port and a reduced port. In the full port design, the body port shall be as large as practicably design consideration permits. However, in no case the net area of the bore through sheet, the globe wall, shall be less than 85% of the area of the actual pipe bore. In the reduced port design, the port diameter is normally one size less than that of the connected pipe. Now next part is bonnet. The body bonnet connection for the globe wall is same as that of the gate walls. Now disc. Here we see the different kind of seats. The globe walls, flat face types, plug type, ball type, needle type, V4 types. So first, flat face types. Discs are used when the wall is to be used for the positive shut-off services. For such services, can use that kind of walls. This can be provided with an elastomer ring or facing, which will ensure the same. The needle type discs are used when the finer flow control is to be achieved. These discs can be also of counter design as used in flow control valves. These are generally used for precise flow control applications, and V-port disc is used for throttling operations. The loops or interval state integral for the disc and used to design the removals. When the fully open positions, the net area between the disc and the seat should be equal to the seats. Velocity is the only way to achieve the N4 in this type of ones. Next component is a stem. Stem, in case of globe wall, the stem is always of rising design along with hand wheel. The stem is provided with the disc nut at the lower end. The stem is provided at the lower end. The upper end is provided with the hand wheel screwed by stem nut. In case of velocil valves, rising stem with non-rising hand wheels is provided similar to that in case of gate valves. Now another next component, gland flange, backing and lantern. Design and detail same as that of gate valves. Now we'll discuss remaining parts in next lecture. Do you have any questions, any doubts? So you can ask your doubts or questions. Yes.
No, sir.
Okay, fine. Yes, Harsh. Now, Ash, Avish Patel, do you have any questions, any doubts, any confusion?
No, sir. No doubts.
No, sir.
Okay, fine. We close this session here and we'll see remaining parts and remaining walls in next session. Okay.
Thank you, sir. Thank you, sir.